All right, this is 3.2 absolute value graphs. We're going to start today looking at the parent function, which the parent function, again, is just simply the most basic function in a family of functions. So we're going to start today looking at Desmos, which is our free online graphing calculator. So I've got this parent function graphed out here, y is equal to the absolute value of x. And now we're going to do some translations here. So let's take a look at the first one. We want to move this function up 3. So let's see how we might do that. Let's start with adding plus 3. Well, look at that. That one worked out. Okay, what's the next one? Move it down 5. Okay, well, if doing plus 3 moved it up 3, to move it down 5 would probably just be minus 5. Sure enough, that worked out. So let's go ahead and write these down in our notes here. So if we want to move our function up 3, it's going to be y is equal to the absolute value of x plus 3. If we want to move it down, it's going to be y is equal to absolute value of x minus 5. Okay, so we're going to kind of scroll down here and take a look at this general equation of absolute value. And we're going to kind of slowly take this piece by piece, okay? So it looked like if we wanted to move our equation up and down, it was our number outside of the absolute value bar to the right, okay? So it would be our k value. All right, so it looks like this value, whatever k is going to shift our function up or down. Okay, let's keep moving on. Let's look at this next one here. How does this move it? Okay, let's take a look. So let's get rid of this negative 5. And we're going to put the plus 2 inside the absolute value bars. All right, interesting. So it looks like it shifted it to the left 2. Okay, you might have thought, I know when I first looked at these, I would have thought that this would have gone to the right, but it actually shifts the function kind of in a counterintuitive way. So let's go ahead and write that down. So how does it move it? It goes to the left 2. All right, let's look at this next one. How does this move it? So y is equal to the absolute value of x minus 6. Well, if plus 2 moved it to the left, maybe minus 6 moves it to the right. Let's take a look. All right, sure enough, it did. It moves it over to the right 6 on the x-axis. Let's go ahead and write that down. To the right 6. All right, I think we got another piece to our puzzle that we can add in here. It looks like this h value is going to shift our function left or right. Okay, moving on. Well, let's take a look at these last two here. So if I wanted to move my function to the right 3 and up 5, okay, so we're going to start with y is equal to the absolute value of x. Now, if I want to go to the right 3, that's going to be a little bit counterintuitive. So I'm going to go subtract 3, close the absolute value bars, and then up 5 is just going to be plus 5 outside. Okay? How about this one? Move it left 4 and down 5. Okay, well, left was like this one, which was plus inside the absolute value bars. So this one's going to be y is equal to the absolute value of x plus 4, and then down 5 is just going to be minus 5. Okay, now let's take a look at reflections. Let's first start with the parent function here. Y is equal to the absolute value of x. And let's just start with the first x value here, -2. So when x is -2, the absolute value of -2 is +2. So y is equal to +2 because absolute value is always positive. Okay, so that's going to be +1 here. 0 is not going to change. Absolute value of 1 is also +1. And absolute value of 2 is +2 as well. Okay, so now let's take a look if we have this negative out in front. So if I have y is equal to negative absolute value of x, let's put in our -2 value in. Well, the absolute value of -2 is +2. And then you can think about this as just kind of dropping down in front of it. And so then we're left with y is equal to -2. All right, and that's what's going to happen with all of these. Okay, so -1 is going to become -1. 0 is obviously not going to change because there's no positive or -0. Let's just try number one. X is 1, just to see what happens here. Absolute value of 1 is 1. This still drops down in front, and we get -1 again. And so this is going to be -2. All right, so let's go ahead and first plot this one out here. So at point -2, +2, so x-axis, y-axis, if I go back 2 on the x-axis and up 2, that's right here. Next point, -1, +1, that's right here. 0, 0 is right there. And now we're getting into our positive. So we got 1, 1, and 2, 2. And there we go. There's our parent function. Not very good graphing, but that's okay. And now let's take a look at this one here. So now we'll start with the first one, -2, -2, back 2, down 2. That's right there. Back 1, down 1. That's right there. 0, 0. We already got that plotted out. And then +1, -1. That's over 1, down 1. And the last one, over 2, down 2. All right, so there we go. We connect those points with our line. So what does it look like happened here? When you put the negative out in front, it reflects, can't spell, flex over the x-axis. Okay, so now let's take a look here. If I want to move our function left 4, up 3, and flip it. Okay, well, let's start with y is equal to, if we're flipping it, we're going to have the negative out in front, and the absolute value of x left 4, which means it's going to be +4 inside here. Close it up, and we're going up 3, which is going to be +3 on the outside to the right. So there we go. All right, moving on. So now we're looking at transformations, which is kind of like we're going to be stretching or shrinking our function, making it flatter or steeper, okay? And so you can think about a value in front of here of 1, okay? So here's our parent function. The vertex is right at 0, 0. And basically what we're doing is we're going over 1, up 1, over 1, up 1, over 1, up 1, and going in the opposite direction as well. Okay, so there's our parent function graphed out. So I want you to think of this value in front of the absolute value bars as kind of like your slope. Okay, so for this one here, our value in front is 3. So let's think about that as 3 over 1. The vertex hasn't changed. The vertex is right at 0, 0. But we're going to go up 1, 2, 3 over 1, up 1, 2, 3 over 1. And this is going to reflect across the y-axis. So if I'm 1 away from the y-axis here, I'll be 1 away from the y-axis here. And same thing here. If I'm 2 spots away from the y-axis on the right side, we're going to be 2 spots away on the left side. And there is our function, kind of squished together, making it a little bit more steep. All right, now this one, again, our vertex hasn't changed, so that's right here. And we're going to go up 2 over 5, 1, 2, 3, 4, 5. And again, we're going to reflect over the y-axis. So if I'm 5 spots away to the right on the right side, I'm going to go 5 spots in the other direction. 1, 2, 3, 4, 5. It's going to be right there. Okay, so now let's take a look at our last thing for the general equation of absolute value. This A value is basically going to determine our slope. And it will tell you how flat or how steep the function is. Okay? All right, and last thing. So we've gone through everything except for the vertex. The vertex is going to be h comma k. That value will tell you where your vertex is, and of course the vertex is this point. Okay, if it's reflected going down this way, the vertex would be here. Okay. All right, so now let's look at some of these practice problems that we got. So the first thing you're going to want to start with is finding the vertex. Okay, and so remember that this value, this h value, is kind of always the opposite of what you think it is. Okay, because it's our equation. I'll write this out here. All right, because this is a negative h, it's going to make this, whatever value is inside here, it's going to make this the opposite. Okay, so our vertex is going to be positive 5. God, that's bad 5. There we go, not much better, but our vertex is going to be positive 5, and then this one's pretty straightforward. This one's just going to be whatever it is. So our vertex is going to be at 0.52. So we're going to go over 1, 2, 3, 4, 5, up 2, and there's our vertex. Now we're going to follow this value as the slope, and so think about that as 2 over 1. So we're going to be going up 1, 2 over 1, up 1, 2 over 1, and then we're going to go in the other direction as well. So up 2 over 1, up 2 over 1, and here is this function. All right, let's look at the next one here. Let's first determine the vertex. So again, that's always that value inside the absolute value bars to the right of x. So if there is none, that means our x value is going to be 0. And this one is our k, which is 3. All right, so that is 0.03 right here. There's our vertex. And now we're going to follow our slope, negative 2/3. So we're going to go down 1, 2 over 3. 1, 2, 3. That's right here. And then I would just go, if I'm 3 units away on the right side of the y-axis, I just go 1, 2, 3 in the other direction, and there you go. So here is that. It's not a very good drawing, but there's that function. And then here's the flip side of this. We're given the function graphed out, and we need to fill in everything else. So let's see, let's start. We know it's going to be absolute value something. Okay, we might have something in here, might have something out to the side, and we might have an a value. So let's start again with the vertex, just like we did with the other two. So the vertex is at over 1 down 2. So the vertex is at 1, 2. And remember, this value is pretty straightforward. This is going to be plus 2. But this one's kind of the opposite, right? If this is positive 1, it's going to be negative 1 inside the absolute value bars. And now the a value is going to be the slope. So let's see, how do we get from the vertex to this point here? We're going to go up 1, 2 over 1, 2, 3. So there is our a value, and that's it. All right, last thing, looking at domain and range. Okay, well, domain is going to be pretty easy because if we're looking in terms of, on the domain is the x values, right? Well, if I'm looking for the smallest value of x, I notice that these are arrows, so these keep on going forever. All right, so there isn't going to be a minimum or a maximum value that x can't be. So the domain is going to be all real numbers. And what about the range? So now we're looking at the y-axis, or the f of x axis, and we're going to look, what is the lowest value in terms of y? It looks like that would be right here at positive 2. Is there a max value? No, because if I go way up, let's see, if I go way up here on the y-axis, I'm going to run into some function over here and over here, because these arrows mean they go on forever. Okay, so y just has to be greater than or equal to 2. All right, next one, domain. Again, because these are arrows going off, I'm not going to be able to find a minimum or maximum value for x. So this is going to be all real numbers. How about the range? This one here, if I'm looking on the y-axis, there's not going to be a minimum value, right? Because these go on forever. So even if I go off to the graph here, can extend this. If I'm looking at point, I don't know, there's probably 10 here. If I'm looking at point negative 12 on the y-axis, I'm going to find some function here and over here. And that would be the case if I go down to 1,000, right? So there isn't going to be a minimum value for y, but there is a max, which is going to be here at the vertex at positive 3. So y just has to be smaller than smaller than positive 3. Okay, next one here. Same thing, hopefully you're realizing with the domain, it's going to be all real numbers. And what's our minimum value of y? Looks like that would be in terms of the y-axis. Can't get lower than here, which is at negative 2. And the arrows are going up, so there isn't going to be a maximum value. So this is just going to be y. It has to be greater than or equal to negative 2.